Welcome to teXperts, your experts in tech. Here we explore what makes companies successful in today's world. My name is Miguel, and today we will be talking about embedded machine learning. For this topic, we have Ashwin Krishnan as our guest speaker. Ashwin is the head of consulting for Switzerland and Austria at Orange Business Services and has several years of experience in cloud transformation and automation, mainly in the banking and insurance sector. Today, you will learn what embedded machine learning is and how this technology makes IoT devices smarter and more reliable. Hi Ashwin, welcome to teXperts. I am very happy to have you with us today to learn more about embedded machine learning.
Hi, Miguel. Happy to be here as always.
Good. Do you want to tell us a little bit about yourself?
Yes, Miguel. So I joined Orange Business Services about 20 months ago to lead the consultancy within the Swiss cluster. Orange is currently transforming from being a network provider to being a network native digital services provider. And I have a background having worked across the spectrum as a developer, solution architect, enterprise architect, digital transformation consultant in the banking and financial sector before, for almost about 18 years before joining Orange. So Orange gave me the opportunity to expand to other industry segments. I'm getting to work with customers and clients across manufacturing, pharma, as well as my traditional finance and insurance companies. And this has been a huge learning experience for me.
Mm-hmm. And on what are you working nowadays, Ashwin?
In addition to looking after our consultancy services for the Swiss cluster, I like to collaborate with our global teams to identify and develop new bleeding edge offers that generate value for our customers as well as society, in line with the principles of being a digital native services company. One of the topics which has really got the interest of mine is embedded machine learning, which is also the topic for today's conversation.
Exactly, yes, this is the topic of the day. Before we start talking on the details of embedded machine learning, what is it?
All right. So first, I have to give a caveat. I am not a data scientist by any stretch of imagination. I've had the privilege of working with some very interesting projects that utilize machine learning models alongside some of the brightest minds within Orange. So before we go into embedded machine learning, it's important that we get a layman's understanding of what machine learning is and what are the ways machine learning can be developed for devices, also known as Internet of Things or IoT. So an extremely simplified explanation of machine learning would be, and I apologize in advance to the machine learning experts and purists for this super simplification, but machine learning is a branch of AI, artificial intelligence, which focuses on the use of data and algorithms to mimic human learning and improve predictions, right? So the first step of this is to get data, and this data is then used to create a machine learning model, which by a process called training. And after training, the model is able to predict the outcome based on newer inputs, which is what we call inference. So now in the context of IoT, if you take a device, the first step of the journey to make it smart are add some sensors to it so that they generate data. So we're able to get the context on that. We need to provide connectivity to this device so that this data can be sent to a central store, a data store in place. It's published over there. The next part, which is exciting, is because this is the crux of the intelligence or the device being made smart, is to use this data to identify what is the right machine learning model to be done and then train that machine learning model with that data. Now, after training, this machine learning model will be able to predict or identify outcomes based on live data before they actually occur. So, for example, a machine would be able to predict that it's going to fail, let's say 3 hours or 4 hours from now before it actually fails, so that you're able to take corrective action. So this is basically by identifying patterns and scenarios which were previously missed by human operations. And this is the inference part.
Mhm. Okay, so then the basic difference between traditional, let's say, machine learning or algorithms with embedded machine learning is that we are moving the algorithms, we are moving the computing power from the cloud into the device. And then this enables us to have more accurate models because they are only like developed just with the information, with the data from this concrete device for the conditions where this device is operating.
True. So traditionally, the data from these devices and all similar devices were collated and sent to the cloud. You're right on that front. And this was because traditionally the training of most machine learning more algorithms was computationally intensive. So you had to run through all permutation combinations. There's a lot of very interesting maths behind it, and some of which, I have to be honest, I don't fully comprehend. So the conventional wisdom was the more varied data which you have in place, the larger amount of data which you have for training, the better your model will be because it will be able to cater for those many scenarios in place. So you used to create one model across all the device instances. So if you had 1,000 motors, you would have one model which is created from data which is pulled from all the 1,000 motors, or at least 8,000 motors, or like that.
And what is the difference between embedded machine learning and the traditional machine learning?
Absolutely. So what I previously described before is what I call as centralized learning, right? Now, before I jump to embedded machine learning, it's also part where I want to bring about the edge computing platforms and capabilities which come there in place. Most of the manufacturing companies and most of the devices work with some latency requirements and connectivity limitations which are not suitable for the inference to happen on the cloud. So that's why there were a whole bunch of solutions which came forward. Our cloud vendors like AWS, Azure came up with their respective edge compute platforms like Greengrass, Azure IoT Edge. There are also a bunch of custom edge clouds which you could develop, which are able to run these inference at the edge. Now let's call that edge inference. Now, the experts in the field always advise us to use the simplest solution as possible from a machine learning complexity perspective. So where a regression model could work, you don't necessarily need to use a neural network in place. And that's basically from a cost of compute capability which is there in place. Over the last few years, experts have identified a subset of machine learning algorithms which have a small enough footprint so that they can be trained on the edge in constrained environments like a microcontroller. This is embedded machine learning. We are working with our partners who are pioneers in this space to operationalize and scale out EML implementations to actual customer problems.
Mm-hmm. Okay, so that means now, thanks to embedded machine learning, we can train the machine learning models directly at the edge.
Yes. Not all models, only a subset of them via a concept called incremental learning. But the subset is pretty comprehensive for most use cases that we've come across.
Mm-hmm. Like, for example, what are the most normal or the key use cases for embedded machine learning?
Embedded machine learning is able to be used for a variety of cases like predictive maintenance, like battery maintenance. For example, also there are more interesting use cases like setting up a virtual sensor itself, where embedded machine learning works in tandem with centralized learning itself.
Mm-hmm. Right. Okay. And how does this impact, or what are the reasons a manufacturing company should be interested on embedded machine learning with this kind of use cases that you have mentioned?
So that's a very good point to look at. So the key advantages of this technology are that because the training happens on the edge, this happens much faster than training on the cloud because this is working with a much smaller subset per data. So in our projects, we have seen EML model generated with 20% of the data per device as opposed to centralized learning, right? These models continuously learn and adapt to the context of the device. So example, if the machine operations change during summer versus winter, in centralized learning, you will need to adapt your model and then deploy it again. Whereas these models, since they are on device, are able to transform or metamorphize to this context in place. The second part is, after speed, we look at in terms of cost. So the amount of data to be transmitted from the device to the cloud is significantly reduced. Now, take a hypothetical example. If you have an electric motor, which, let's say, this is not exact case, but hypothetically generates 1 megabyte of data per hour from its sensors. In a setup of, let's say, 1,000 motors, this will be about 24 GB a day, about 480 GB a month, excluding weekends in place. With centralized learning, all of this data needs to be sent to the cloud, and we will have additional bandwidth requiring to download the generated machine learning model afterwards, right? And every time the model is adapted, we need to have a similar setup in place. But if embedded machine learning is applied over here, this would drastically reduce the bandwidth consumption because none of this data needs to go to the cloud. You would have some level of device management if you're using the cloud to do that. But other than that, none of this device data needs to go to the cloud, which saves all this bandwidth data.
That's a very good argument for exploring what embedded machine learning is. Absolutely.
Yeah. And this also brings back to the contextualization, right? So we talked about the previous, historically, why we needed data from varied data, because you want to have a model which was one size fits all, as you could call it. And this has been one of the biggest issues of machine learning, where if you get just one set of data, you have an overfitted model, which is not able to take care of all scenarios. But with embedded machine learning, we're actually creating a model per device, which is trained on its operating conditions, its context in place. So a motor running in the Sahara Desert versus a motor running in Stockholm versus a motor running in Mumbai in more, let's say, salty and humid conditions, they all operate in different environments, and they will have different characteristics in terms of their lifetime, in terms of their predictions which need to be happening. And by having a model which is contextualized or personalized to that setup in place, we are able to get much more accurate readings. And last but not the least, in some scenarios, whether it's for regulatory reasons or other reasons in place, since no device data goes to the cloud, we're able to address data privacy and data residency requirements, should that be a need or case.
Okay, so then we have said that embedded machine learning is helping to reduce the bandwidth costs,
right,
for the IoT connected devices. Mm-hmm. Then the other reason is we are creating more accurate inferences for each device. What are the other reasons a head of innovation or head of product development should be interested on this technology?
There are a couple of very interesting use cases we are exploring with our customers and partners with this technology. Some of them are still work in progress. I have to give that caveat. So one of the interesting things which I mentioned before was virtual sensors. So in many devices and installations, we found that it was not viable to install additional sensors, which would be required to get the data as needed by the centralized machine learning models in place. So we work in tandem with the centralized training approach to set up what I call as a virtual sensor that predicts the sensor value based on other scenarios. Let me explain that with an example. So in a motor, sometimes it's difficult to put a temperature probe, right? So based on the pressure and vibrations of the motor, we are able to predict the temperature. And now more complex machine learning models can leverage this data from the actual sensors as well as the virtual sensors to make the complex models in place. This is a classic example of how embedded machine learning kind of cooperates or coexists with centralized machine learning. One of the specific use cases where we've seen good results are for battery management of electronic devices, because with the push towards electrification and electric devices more and more, one of the biggest factors over here is battery management. How could you increase battery life? How could you efficiently use batteries in place? And due to different operating conditions of a battery, let's say a battery operated on a crane or a hand drill, we are able to create customized models that optimize the battery consumption, the battery charging, all of that, thereby increasing the battery life to a significant amount. And this is good not just from a cost perspective, but also from an environment perspective. The third area which we begin to explore are with consumer electronics. We're trying to see if we can leverage this aspect of personalization of the model. So, and that would lead to a much better customer experience. So for example, my smart coffee machine, which is operating in Zurich, knows the brand of beans which I'm using, and based on the Zurich weather patterns, based on the Zurich environmental context, as well as my preferences, knows that my beans need to be heated to 200 degrees Celsius to get my favorite brew, as opposed to maybe yours or maybe someone in Chennai where they need to be doing that at 220 degrees because the consumer's tastes were different, the brand of beans was different, the temperature in Chennai or the temperature in Hamburg is different as opposed to what's in Zurich, right? So we constantly look for new use cases to co-build with our customers. So here, if any of our listeners are interested to explore this, please get in touch with me.
Good. And I mean, what is the catch, Ashwin? Because you are telling me a lot of benefits of using embedded machine learning. There should be something hidden that makes it a little bit more complex in reality.
Well, it's not hidden, but it's a very important point. And I'm not saying that embedded machine learning is the next best thing after sliced bread. So as I've always said, not every machine learning model is compatible with AML and incremental learning. So use cases which involve deep neural networks, for example, video analysis or image classification, are not best suited for this technology. So it's extremely crucial that the team and the data scientists explore the possibility of a simpler model and establish that there is a possible use case with this kind of scenario. It's an investigation process. It's a discovery process which needs to go forward with. The second aspect which we are looking at is in terms of model governance to keep in mind, because each device has its own model. We are currently exploring the feasibility of what I call federated learning. And this is a very complex topic. We probably need to have a totally different session and maybe a couple of experts more knowledgeable than me to dwell on that topic about how we learn from models rather than learn from data. But that's a very, very interesting area. But as these topics come forward, they do add complexity should you want to be having this kind of model governance.
So this is something that we can arrange, of course. And so then, I mean, what I have understood is we cannot apply or we cannot move the machine learning algorithms into all the edge devices. This is something that we have to analyze in detail, and therefore we need some kind of exploration project for understanding for what kind of data, for what kind of use cases embedded machine learning is better suited for before jumping into moving everything to the edge. And are there any other non-technical challenges for applying embedded machine learning?
Well, the challenges are not specific to embedded machine learning, but overall to AI ML in general. And this could be a whole session on its own, but I will try to summarize these into the 4 areas which I talk about. One is data. So with machine learning, it's garbage in, garbage out. If you do not get the right data in place, your training will be incorrect and ergo your inferences will be incorrect. With embedded machine learning, this is still reduced to a large extent, but you still have to focus on ensuring that you get the right data, which is representable for the model, even if it's be created specific for the device. The second aspect, which is a bigger challenge, is the structural issues in business processes. So it's important for business processes to understand how does AI ML fit into the way they operate. And it's machine learning and AI is probabilistic in nature. So we are tuned to thinking that if this, then that. That's how most business processes work. But if you, let's say, example, ask a machine learning model for object detection. Is this a picture of a cat? In traditional ways, it'll be yes or no. Whereas machine learning will say, I'm probably 90% sure that this is a cat. 10% maybe not. So how do you handle that? How do you handle false positives? How do you handle false negatives? What is the impact of that? That's the business process redesign to handle probabilistic responses, which is going to be critical. This third part is cultural, and despite AI and ML getting so much of hype, there's a lot of expectation mismatch within organizations. Either some consider it to be a miracle cure to solve everything, which it can't today because not everything can be solved by AI and ML. Or there's a fear element. I mean, and movies like Terminator and Skynet or Matrix have not exactly helped with that idea of AI ML. And we are not there yet. And I don't think we'll be there in any time in the near future. So the understanding of the limits of AI ML is quite low. And this is also important because this is a moving target. Every day, every minute, every second, the boundaries of this are being pushed. So it's important to be having that culture to be so that you're able to leverage the best out of AI in your processes, in your business setup in place. And last but not the least, with any bleeding edge technology, there is a war of talent. So a shameless shout out here from my side to any data engineer or data scientist out there. If you're interested to work in challenging AI ML projects, give me a shout out. Feel free to reach out to me over LinkedIn, and we'll see how that proceeds.
Yes, we will put Ashwin LinkedIn link on the description below, and then you can reach him out directly if you want to know more about embedded machine learning, or in general to discuss about technology or any other topic that you could find relevant. Good. Then, as a summary, let's say embedded machine learning is a technology that is helping to have IoT devices less dependent on the bandwidth, without latency, reducing the costs for connectivity or data transmission, making more accurate models and more reliable, therefore, because we are talking that each model is specifically developed for that concrete device. And then on top of that, with enhanced or improved security, because the data is not transferred to the cloud, so it stays on the device, and then we have full control on the amount of data that we have within our organization or within our, let's say, infrastructures.
Correct.
Fantastic.
That's a fair summary in place.
Good. Then thank you very much, Ashwin. It was great to have you with us today. Looking forward to following sessions on describing maybe some use cases or having conversations with some experts, as you mentioned. And talk to you soon.
Thank you, Miguel. It was a pleasure being here, and wish you all the best. Take care.
Bye.
Bye.
If you enjoyed today's content and learned something new, please give us a thumbs up and subscribe to our channel. This helps us to grow. You can find us on LinkedIn, YouTube, and Instagram. All of the links are in the description below. See you in the next one.